Good afternoon, everyone. Welcome to our presentation, our lunchtime presentation on the role of Canadian space technology in enabling global transparency in methane emissions with our speaker, Eric Choi from GHGSAT. So we're just going to let people join over the next couple of minutes before I do the introduction and start the project. Presentation.
Yeah, and it's Jeff Bird here. Do think about your questions ahead of time, post them to the chat, and we'll try and feed those to Eric at the end of his presentation. We expect there to be a good portion of the time available for discussion, so do add your questions and comments to the chat. Thanks. Welcome, Abram. I see some. And Gary, Graham, good to hear from you, Michael Ball. Greetings, okay. Malcolm.
Welcome, everyone. My name is Omar Majid, and I, along with Jeff Bird, we are the co-chairs of the CASI Ottawa branch, and we'd like to welcome you to our lunchtime presentation today on the role of Canadian space technology in enabling global transparency in methane emissions. We have the privilege of having Eric Choi, who's Director of Business Development at GHGSAT, to give the presentation today. And he is, over the course of his career, he has held positions of increasing technical and managerial responsibility in both aviation and space sectors, including work in GHGSAT, quantum encryption and science satellite, the meteorology payload on the NASA Phoenix Mars lander, Canadarm2 on the International Space Station, RadarSat #1, Earth observation satellite, and MOPIT, measurements of pollution in the troposphere instrument. So he has a IASC in engineering science and Masters of Applied Science in aerospace engineering, both from UT and an MBA from York University. And he also gave a talk in November of 2017 to the CASI Ottawa branch on sort of Canada's space at the crossroads. So yeah, and he's also a big Trekkie. So without further ado, welcome everyone, and I'd like to turn the presentation over to Eric.
Omar, thank you so much for that great introduction, and hello and good afternoon, everybody, and thank you for your time. As some of you may be aware, this was originally intended as an in-person presentation with a yummy dinner to boot, and normally I'm one of these people who would never refuse an in-person presentation, and certainly with a nice meal to go with that. Unfortunately, that did not take place, although I did come up to Ottawa. But I'm really thrilled to be able to reprise this presentation, at least virtually, for all of you today. So just to confirm, are people actually able to see my slides? Maybe I could get an indication from Omer or Jeff, like a virtual thumbs up.
Yes. That's good. Full screen, good.
Excellent. And I presume that people can also hear me 5x5 as well. So in Omer's introduction, he alluded to the fact that I'm a huge Star Trek fan. And this is pertinent because it was really that sort of thing, that science fictional notion of space that got me interested in this field and ultimately into the industry many, many years ago. And it's very much that notion of exploring strange new worlds and boldly going where no one has gone before, seeking out new life and new civilizations that got me enthralled in this. So the notion of space technology and the Canadian space technology going out there into the solar system, into the universe beyond, and seeing what's beyond the horizon. And nothing perhaps epitomizes this better than iconic images like this one, taken in this case, this being the famous Apollo 8 Earthrise image, rather, taken from lunar orbit in Christmas Eve of 1968. And as powerful as those images are of, we remember, Neil Armstrong and Buzz Aldrin and others, the iconic vision of people on the surface of the moon, it turns out, and I would argue that it's images like this one that are equally, if not more profound, when the astronauts looked back across the gulf of space and saw the Earth as this fragile blue marble in this absolute blackest of black that you can possibly imagine. And I would argue that it's not a coincidence that the first Earth Day event took place less than a year after the Apollo 11 moon landing, so in April of 1970, and building that environmental awareness, this consciousness of Earth as not only a fragile place, but the recognition that space technology, in addition to the exploration aspects of looking out into space, can be very instrumental in looking back at the Earth and perhaps helping to ameliorate and solve some of the environmental and climate challenges that we faced up in today and in the years to come. So GHGSAT is focused on methane, which is a very important greenhouse gas. And I would argue that in some ways, this is a greenhouse gas that until recently has been, kind of forgotten, at least in the mainstream. Everybody talks about carbon dioxide, as they legitimately should. Water vapor is an important greenhouse gas, but what's so important about methane? I think the critical thing about methane is its sheer potency. So in fact, as a greenhouse gas, it's about 80 times, more than 80 times, the global warming potential of carbon dioxide over the first 20 years that's actually emitted into the atmosphere. So that's sort of the bad news. But the good news is that because it is a short-lived greenhouse gas, what it means is that if we can take active steps now to reduce our methane emissions, mitigate these emissions, it has an equally outsized benefit for environmental and climate mitigation. So I believe the figure is something like, if we were to be able to reduce methane emissions by, say, 45% over the next 5 years, this would have the same 20-year climate benefit as closing about 1,300 coal-fired power plants. So given this importance of methane as a greenhouse gas, or really the monitoring of greenhouse gases overall from space, this has been the focus of attention of a number of large flagship missions initiated by space agencies around the world. So some of the earliest greenhouse gas measurements were performed by an instrument called SCIAMACHI. It's one of these long acronyms that I forgot. I think something like Scanning Imaging Absorption Spectrometer for atmospheric cartography, I think is what it's called. And it flew on a massive European Space Agency satellite called ENVISAT, and this instrument operated between 2002 and about over a course of a decade out to 2012. The first satellites that were dedicated specifically to greenhouse gas measurements, there were actually two of them. So it was GOSAT launched by the JAXA, the Japanese Aerospace Exploration Agency, in 2009, and OCO-2, the second orbiting carbon observatory that was launched by NASA in 2014. There was actually an OCO-1, but unfortunately that was lost in launch vehicle mishap. One of the key instruments that is operating right now, and I'll talk about the importance of this one a little later as well, is called TROPOMI, which stands for Tropospheric Monitoring Instrument. And this is on another ESA satellite called the Sentinel-5 precursor mission, or Sentinel-5P. And this instrument has been operating since 2017. If we look to the future, there's an American NASA-led mission called GeoCarb, which is proposing to mount a methane greenhouse gas monitoring instrument on a satellite that's going to be in geostationary orbit. So unlike these other satellites that are in low Earth polar orbits that are constantly moving, the advantage of GeoCarb is that it's going to sort of hang there at a particular longitude, and in its case actually scan wide swaths of North and South America. So what's a common theme of all of these satellites is that they were designed primarily for scientific purposes rather than operational monitoring purposes. And they tend to look at areas, very wide areas. So regional scale, continental scale, global scale, but at relatively coarse resolution. So in the case of Sentinel-5P TROPOMI, we're looking at resolutions on the order of 5 by 7 kilometers. So this was part of a niche that the GHGSat recognized when the company was founded in 2011. So just over a decade ago. So the date of 2011 is actually significant, because one of the key drivers for the foundation of the company was that 2011 was the year that 2 subnational jurisdictions imposed or it started to implement rather carbon pricing schemes. One was Quebec, which is the home province of GHGSat, and the other being California. So it's all well and good to have a carbon pricing scheme, but the gap that the founders recognized, being pictured here, Stéphane Germain, Francois Rodrigue, and Eric Edwards, is that the need to have objective data, actual measurements to know that what you're charging against, because otherwise you are potentially dealing with millions, if not potentially tens or hundreds of millions of dollars in carbon trading based on estimates, in some cases self-reporting, which can be underestimated or it could be overestimated. So it's possible that entities could actually be paying more than their fair share. So there's a need for objective measurement, and this is an area that satellites are uniquely able to facilitate. However, not necessarily the satellites that are currently up there, with these wide swaths and very coarse resolutions of 5 by 7 kilometers. What was really needed is sort of the opposite of, looking at point sources, down to a few tens of meters, so we can actually identify and characterize where those leaks are, where these emissions are down at the facility level. So we've had tremendous success in raising a whole bunch of money, which ultimately led to the launching of our constellation. So the first technology demonstration satellite was called Claire, and this was launched in 2016. And most recently, as of last Wednesday, in fact, we now have 6 satellites on orbit. So last Wednesday, on the SpaceX Transporter 5 mission, we successfully launched our 3 newest satellites, which are named Luca, Penny, and Diaco. And if you're ever curious about where the names of our satellites come from, they're actually named for the satellite, so for our kids, so that the children of our employees, just as a small way of reminding ourselves of the importance of our mission for future generations. So as I said, last week, we launched our newest 3 satellites. It was a very impressive launch. Even my cat Pancake was as much as any cat can be interested in anything, she was mesmerized by the launch last Wednesday as well. So a little bit about those satellites. So I talked about things, like GHGSAT and Skiamachi. If you can imagine, these are enormous spacecraft. So in the case of something like GHGSAT, it was this vehicle was the size of a bus. And ours are, completely the opposite side of the spectrum. So, what we employ are these microsatellites or nanosatellites that you've probably heard about. So, rather than being several tons, in fact, they're on the order of 15 kilograms. And from a size standpoint, you can see this image here for scale of 3 people in the clean room. Our satellites are about the size of a microwave oven. But we like to think that they're, kind of small but mighty. So they do a completely different and complementary niche to what these big government satellites do. So, rather than spatial resolutions on the order of kilometers, we are looking down at tens of meters. So, less than 30 meters, meaning that as I said, we're able to look down and identify methane emissions right down to an individual facility, like a landfill or an oil and gas well, for example, with a relatively narrow field of view. So about 12 by 12 kilometers. So for each individual satellite, we're able to revisit the same point on the Earth, the same facility, about once every 2 weeks or so. But the rationale for building out our constellation to having more satellites is that we can increase at a system level or a constellation level that repeat cycle. So that scales roughly linearly. What it means is that our ultimate goal is to have 10 satellites in orbit by the end of next year. And so that's going to get us down to a system level revisit time of about 1 to 2 days. What's also noteworthy about our satellites is, in addition to the high spatial resolution, we have a very low emission detection threshold. So on the order of 100 kilograms per hour is what we're able to detect as a lower limit in terms of a flux or emission rate from space. And this is in contrast, complementary to these other government satellites I've mentioned that in their cases would be, thousands or tens of thousands of kilograms per hour. But I emphasize that there's nothing we do that replaces any of these government satellites. And in fact, this is an entirely complementary capability, which I'll get into a little more detail later in the presentation. So in addition to the satellite sensors, we also have a complementary aircraft sensor. And we did this a little bit backwards. For those of you who are familiar with the way things are usually done in space, you kind of test your instrument maybe on a balloon or an aircraft first, and then you send it into space. We actually did it the opposite way, where we developed the satellite sensor first and then adapted this to fly on an aircraft. So we have 2 of these operational aircraft sensors right now doing campaigns. It's been doing campaigns across North America for the last 2 years. And given that it's on an aircraft and operating commensurately at a much lower altitude, we see corresponding improvements in both resolution, spatial resolution, and detection threshold. So about an order of magnitude better. Looking at about potentially up to 1 meter resolution, depending on the altitude of the aircraft, nominally at about 10,000 feet above ground level, and an order of magnitude better detection threshold. So about 10 kilograms per hour in the case of the aircraft. What I'd like to do a shout out to at this point, what I think is very important, is that GHGSat does not stand alone, and we rely on partnerships, a real Team Canada approach with partners across the country. And what is really remarkable, I think, about what we've been able to do with greenhouse gas monitoring is that the entire solution, almost the entire technological solution is done in Canada. We can do it all here. So, our partners at ABB in Quebec are our partners in building the satellite sensors. The aircraft sensor I mentioned is built by Honeywell in Ottawa. The spacecraft buses, these small but mighty nanosatellites, these 15-kilogram little satellites, are built at the Space Flight Laboratory at the University of Toronto, not far from where I am right now. And we rely on our partners at Secor in Newfoundland and Labrador for the ground segment, for taking data down from our satellites from the Secor network of ground stations. So, we can do all of this in Canada, except for the launch. So we, most recently, of course, last week we launched on SpaceX. We've launched in the past on Indian vehicle for PSLV, for the tech demo satellite, and a Vega. And so, yeah, all of this can be done in Canada. And as for the launch component of it, there's people working on that in Canada as well. All right. So what's the importance of this? What are we trying to do? So as I said, the raison d'etre, the founding of the company, was to be able to operate our own aircraft and satellites to detect and quantify methane emissions, basically from any facilities around the world. So our primary users and customers right now are in the energy sector, in oil and gas. We have stakeholders in the waste management sector, looking at emissions at landfills, for example. Resource extraction, so coal mines are a significant source of methane emissions, and fugitive emissions. And I'll talk about this this particular observation of Central Asia, Turkmenistan, a little bit later in a subsequent slide. So in terms of applications, there's a lot of talk about, ESG metrics, investors wanting to understand the environmental, sustainability, social, and governance aspects of where they're putting their money. As a very practical standpoint, that, people are going to be able to start paying premiums for a source of energy or a resource that is from a cleaner jurisdiction from a carbon emission standpoint than another. So, satellites being a critical aspect of being able to quantify and track, basically from an extraction of, say, a cubic meter of natural gas from source A, or a kilogram of aluminum from this jurisdiction versus the equivalent from another jurisdiction. Well, being able to tell the total carbon footprint of this one versus the other one, and having investors and other stakeholders being able to put their green investments money into the appropriate places. So this is also supporting government and regulatory needs as well. General stock taking and verification and building up of inventories at both the national and the subnational levels. So some pretty pictures here of some examples of what some of these observations would look like. So there's two examples here taken from the aircraft instrument of a methane emission from an oil and gas facility in the Permian Basin region of the southwestern United States, so Texas. So again, this is about a 1 meter resolution. The color fever chart there you see is basically the concentration of methane in parts per billion in this case, and this is the excess amount of methane over the overall background of the scene. So in this case, the emission plume, this concentration, is overlaid over the monochrome context image that's taken by the same instrument on the aircraft. So I'll show now some examples of our satellite observations. You may have seen recently a press release we put out that we were able to detect cow burps or cow farts, I guess, if you will, for the first time from space. This is, in this case, being a feedlot outside of Bakersfield, California, that was taken by Hugo, our second commercial satellite, back in February. And so this was a fairly significant emission here, almost 500 kilograms per hour. Have another example here. This is in the energy sector. So this is an oil and gas well in the Montney region of British Columbia near Peace River. Again, sort of the same order of magnitude of emission, about 500 kilograms per hour, taken again by Hugo just in March of this year. So in the previous image of the aircraft, the background context image was from our own instrument. In the case of a lot of these satellite observations, we overlay our concentration data with just commercial imagery from, Google Maps or Google Earth or Bing or Mapbox or what have you. So if we were to look at the scientific literature of what the characteristics of these methane emissions are, for example, in the oil and gas sector, we see that what it follows is a bit of a long tail distribution. And what that means is that, in fact, a relatively small number of sites disproportionately contribute to the amount or the total volume of methane that actually goes into the atmosphere. So basically, about 5 to 10% of the sources contribute over 80% of the methane that goes into the atmosphere. And this is significant because a lot of the traditional methods of detecting leaks, which consist of terrestrial methods of literally a person holding an infrared camera or an optical gas imager and going in there with a truck, tends to catch the small emissions easily, where the big ones, the small number of 5 to 10% that actually contribute the vast amount of by volume of the emissions, keep going. And this is where the value of satellites and aircraft observations, remote sensing, come to the fore, that we can detect these large emissions are actually doing, having the most negative climate impact, and then strategically deploy the ground sensors and the ground crews to do the repairs and mitigation in a much more focused and efficient way. So what you're looking at here, that the curve is on the left is a theoretical curve from a foundational paper by Adam Brandt of Stanford University that was published, I believe, back in 2016. And to the right, it's not quite a complete chart, but just some of the data that we've collected ourselves from both the aircraft and the satellites, showing very clearly that we are actually following that. In practice, it's the same type of long tail distribution that was called out years ago in the scientific literature. And I'll say, sort of as a stay tuned thing, Dr. Brandt has an upcoming paper that characterizes a little bit more of what we at GHGSat and other remote sensors have been able to do in the last couple of years. Omer, did you have a question? I see a raised hand here.
Yeah, I just wanted to know what the x-axis was on your last slide.
Oh gosh, I'm sorry. So the x-axis is actually it should be kilograms per hour. So that's the emission rate. And I noticed that label was cut off. And then basically the y-axis is basically the total volume of emission that could be attributed to any individual source.
Okay, thanks for clarifying.
Yeah, thanks for that. So what this calls for is knowing that this is what the distribution is like. For example, in this case, the energy sector, it calls for a strategy where we can synergistically use aircraft and satellites and then people on the ground together in a complementary, multi-scaled or tiered way. So we can imagine a scenario where we use satellites to detect frequently and with wide coverage the largest leaks, say the largest 40% of leaks by volume, And where there are high priority areas, we can dispatch aircraft, say on a quarterly or like a biannual basis, that detect the next 40% of leaks by volume. And then basically the last 5 to 10% of leaks by volume, this is where you deploy the people to go out with their handheld sensors. And more importantly, the big leaks that have been found by the aircraft and satellites, prioritize and shut those down first. So going back to my earlier slide at the opening of this presentation in terms of what the different space agencies around the world has done. And I was very careful to emphasize that nothing that we do at GHGSat replaces anything that is being done by space agencies, and indeed it's very complementary. And so I'm going to elaborate a little bit more about this on this slide. So since 2019, GHGSat has had an ongoing scientific collaboration with the Sentinel-5P Tropomi science team at ESRON. This is the Dutch Space Research Institute. So what's happening here is that because Tropomi and instruments like Tropomi, as I said, look on a wide scale over swaths of thousands of kilometers with a low resolution of few kilometers, they can detect areas where basically there's, hey GHGSat, here's an area of elevated methane. And then based on that trigger, we do sort of like a tip and cue type of thing, where then our satellites, the GHGSat satellites, are kind of like the microscope where we can zoom in and actually identify where was that source of the elevated regional scale emission that was picked up by the government satellites or the government instruments like Tropomi. So so I'd like to show perhaps an example of that right here. So this took place actually last year. And it began with one of these European Space Agency satellites detecting elevated methane emissions in Central Asia, in Turkmenistan. So then a GHGSat satellite was tasked to find out what was going on here, and we actually detected not one but 8 discrete natural gas emissions. And this was, I believe, one of the first times that so many emissions were picked up by a satellite. So what you're looking at here is probably a combination of leaks from pipelines and unlit flares. So in the industry, for various reasons, to relieve pressure and so forth, there are times when methane is just vented, and the slightly less worse practice is to ignite that. So at least you can burn that off and you're generating carbon dioxide as opposed to methane. But unfortunately, in cases, there are unlit flares that are just venting into the atmosphere. And this was what was happening in Turkmenistan. So GHGSat, having observed this, worked through a number of different diplomatic channels, both within Canada and the European Union. And ultimately, indirectly, we were able to contact the local operator of this, make them aware that this was going on. And for a time, it was shut down. Now, unfortunately, we've looked at this part of Central Asia, this part of Turkmenistan again a little more recently, and coming in just the last couple of months. And unfortunately, it looks like these leaks have sprung up. These emissions have sprung up again. So we're going through the same process of trying to go through diplomatic channels to try to get this resolved once again. This is another example, also from last year. So again, a European satellite found elevated methane, a part of Bangladesh. And so a subsequent follow-up with the GHGSat satellite, Hugo in this case, we actually identified the source as a municipal landfill outside of the capital city of Dhaka. And again, this was a pretty big emission, not quite as big as the previous one that I showed of Turkmenistan, but this was on the order of 4,000 kilograms an hour, which I'm told is equivalent to something like 190,000 cars operating for a year. So again, we are able to, through various government channels, contact the responsible authorities in Bangladesh. And as a result of that, the Bangladeshi Ministry of the Environment and Climate Change was notified, and they struck up a technical committee to assess what might be feasible to be done to reduce these types of emissions in the future. So late last year, October and November, was of course the 26th Congress of Parties, the 26th United Nations Climate Change Conference. There were a number of significant developments that came out of COP26, including a bilateral China-US climate agreement, and also something called the Global Methane Pledge, which Canada is one of the signatories to, along with over 100 other countries, with a commitment to cut methane emissions by 30% over, I think it was over 2020 levels, by within basically now the next 8 years, by 2030. But from GHGSat standpoint, what we're particularly pleased about is, thanks to the support of Sustainable Development Technology Canada, we were able to announce and commit that we will be providing our methane data into something called the IMEO. So this is the International Methane Emissions Observatory. This is a program that is led by the United Nations Environment Program with the support of the European Commission and the International Energy Agency, rather. And what this is going to be a clearinghouse of methane data from any number of sources, from satellites, ground sensors, aircraft, national reported inventories, that will be brought together and aggregate as a source of objective information for policymakers, and ultimately to identify areas where it might be necessary for the UN, the UNEP, or other organizations to support diplomatic action to advance the mitigation of climate change and the and methane emissions specifically. So I'll close off a bit, again, sort of emphasizing the synergies and the complementarity of commercial Earth observation ventures like ourselves and others, and how they match up with the objectives of governments and space agencies. So the European Space Agency has a program called TPM, which stands for third-party missions, and basically they make use or they acquire data from commercial entities such as ourselves, and then they make that data available for free to advance both the internal Earth science objectives of the European Space Agency, and to make that data available to the wider European science community. And so we're very pleased that it was certainly a big week for us at GHGSat last week with the launch of the 3 satellites, Diaco, Penny, and Luca. But the day before the launch, in fact, it was announced by the European Space Agency that GHGSat is now officially and fully an operational third-party mission under their program. Our data had been evaluated by European scientists as part of the pilot of this program for about a year and a half. And so it was really gratifying that basically our data passed with flying colors. And as of last week, we are fully and officially a third-party mission under the European Space Agency. And analogous to that, we are starting a very similar process with NASA. So NASA has an analogous program called CSDA, which is Commercial Smallsat Data Acquisition. So we are just getting started now with the evaluation process with NASA. And as part of that, this is a bit of an eye chart screen grab here, I apologize, but this is a solicitation that NASA has put out to the US scientific community, asking for researchers to submit proposals that would basically exercise and evaluate data from GHGSat, ourselves, and a few other vendors as well. So I'll add perhaps that Canadian researchers are actually eligible to apply for this program. The wrinkle here is that NASA cannot fund researchers outside of the United States. And nevertheless, if there's any Canadian researchers who are interested in this, perhaps they could partner with a U.S. researcher or a European researcher in the case of NASA TPM. I'll also mention as well, there's actually a third program that we do through the European Space Agency and the Canadian Space Agency, where we offer 5% of the data from our second satellite, IRIS, for free for non-commercial scientific research purposes. And I'll mention as I start to close that the synergy between commercial data providers, commercial satellite operators, meshing in a very complementary way with meeting government objectives is starting to be recognized in Canada as well. So there was a Canadian federal government Earth observation strategy that was released at the start of the year. And one of the things it does call for, in fact, is for the government of Canada to start exploring new data sets, launch pilot programs to look at what commercial entities can provide in the way of Earth observation. So this is a very promising development, and we hope that Canada will implement this and be in lockstep with our international partners at NASA and ESA. And this is actually my last material slide. To say that, at the end of the day, all we do, it's these type of numbers that sort of motivate us to get up in the morning and do what we do. So, just last year alone, we detected 143 million metric tons of methane, carbon dioxide equivalent of methane emissions, of which the actions that we took resulted in about 2.3 million metric tons equivalent, carbon dioxide equivalent being mitigated. And I think this is something like, 500,000 cars, being operated for a year. And these are the numbers that really matter to us, that, as I said, get us going in the morning and keep us motivated to do what we do. So with that, I thanks so much to everybody for your interest and attention, and I'll be happy to take some questions.
Okay, thanks, Eric. That was very interesting. The kind of combination of business and science and impact on the world is most gratifying, and also your shout out to Canada's capability to do this is most welcome. There are two questions from Malcolm Imray that I could ask him to unmute and ask if he wants to do that, or I can do it. Malcolm, are you there? Maybe not. Okay, so his first question was, I'm interested in the business model for GHGSAT. Who are the customers? And I guess maybe I might expand on that and say sort of the commercial customers and any government regulatory ones, because those seem to be two classes of people that would be interested in this. Go ahead.
Yeah, right. So Jeff, I guess Todd allowed me to unmute. So, but you've gone ahead and asked my question.
You can do that.
I've got some experience with airborne GIF.
You do the second one. Go ahead, Eric, on the first one.
Go ahead.
Great. Yeah. So thanks for that question. Our primary customers to date, our anchors, if you have been on the commercial side. So very specifically and very importantly in the oil and gas sector. So you can probably look at our press releases and see the by name, basically, most of the majors and super majors that you can probably think of are our partners and customers. So I mentioned as well, customers in resource extraction and in waste management as well. Now, it's interesting that Jeff Bird talked about science and government regulators. So, our capabilities initially, going back to the founding of the company, we're very much focused on the commercial sector and the needs primarily and importantly of the energy sector. And we've sort of come to the realization that the technology and capability we have, it should be really valuable from a regulatory standpoint for government regulators and for scientific users as well. So hence the engagement we have now with ESA and with NASA. And in terms of regulation and government users, we recently completed a successful 5-month trial with Environment and Climate Change Canada. So this was a trial that was supported through the Innovative Solutions Canada program. They were very happy with the results that we were able to get. And so, discussions are underway that hopefully we can do more.
Okay. Malcolm, do you want to do question 2? Are you still unmuted?
Sure, I'm happy to do that if you can hear me all right.
Good.
So I'm just curious, you mentioned the sort of revisit cycle for the satellites, and of course I guess it's kind of on-demand cycle for aircraft detection, higher resolution. But is it possible for an emitter to know that detection cycle and therefore to kind of plan their investments in such a way as to incentivize somewhat underhanded behavior, wherein they would store their emissions and then release them when they know they're not being watched?
That's a very interesting question. So, perhaps to clarify, and I apologize, I may not have been entirely clear in my remarks, is we both the aircraft and the satellites do need to be targeted. So we do need to know and be told where to point and have this 12 by 12 kilometer field of view. And this is where the value of operating synergistically with these other satellites that have a very wide field of view, but a much lower spatial resolution and much lower detection threshold, working together. In terms of being able to, I guess, as you say, sort of go dark and sort of duck detection. Maybe two comments on that. And one is that that's very much the rationale for building out our constellation to the full 10 to increase that revisit cycle. The second thing I'll mention is that we're not the only ones out there doing this. No, we're the leaders right now. We're the only ones that have an operational constellation that are doing this, but there's going to be more. There's going to be, for example, METHANE-SAT from the Environmental Defense Fund. And then there's another venture called Carbon Mapper in the United States that are expecting to launch in a few years. So there's going to be more and more eyes in the sky out there that's going to make it increasingly, supporting that transparency that is in the title of this presentation. So it's going to get harder and harder to hide. The second point I'd like to bring to that is that, in fact, the vast majority of the operators out there do not want to hide. And that's why there are customers. They want to know where the problems are so that they can fix them. And not only from a regulatory standpoint, but there is more and more public and investor and shareholder activist pressure in terms of ESG metrics. So companies are, in fact, very, very motivated to make use of these capabilities to help themselves clean up their act. And maybe as a final point, it's also in a direct business interest, because any leaks that they have is product that is going out into the atmosphere that otherwise they could be selling for money. And so there was a very compelling case. I attended an EPA workshop a few months ago where there was an operator in Texas that made this very point, that in fact their methane mitigation activities transitioned from being a regulatory activity to a profit center, because they were actually making money from the methane that was not going into the atmosphere, and that it more than paid for the repairs and the regulatory obligations that they needed to make.
That good, Malcolm? Okay. Move on to the next. There's a comment maybe from Gerard. Do you have confidentiality agreements with your commercial customers? If so, is there a risk that some data would be hidden from the public because of that?
Okay, so that's a very good question. So for our commercial activities, if the operator or the customer desires it, we do offer a sort of confidentiality and a holdback that basically, we would basically not share a given observation with anybody else for like a limited period of time. Less than a year typically, and then it goes out as as a public good if need be. I would say that, to my knowledge, almost nobody has availed themselves of that, and I think it goes back to my earlier comment that almost everybody that we've dealt with, they actually, the energy companies actually want to be a part of the solution, and they're really not trying to hide anything. That it's in their interest to have these observations and to mitigate climate change as well.
Okay, good, thanks. Comment from Frederick. Super nice presentation. Good to see you on GHGSat. He said you might include the Japanese GOSAT 1 and 2, which G1 was the first satellite fully dedicated to the measurement of GHGs, launched in 2009. These satellites aim at measuring high precision the average level on Earth and its slow growth year after year. Part of these GHG sensing instruments also came from Canada.
That's right. Is that Frederick from ABB?
Grand Mall?
Yes, thank you, Frederick, and thank you, ABB, for our instruments. That was certainly an oversight on my part. I had intended to talk about GOSAT, I think in my second or third slide, when I had those images of the historical spacecraft out there. So I apologize if I failed to do that, and thank you, Frederick, for pointing that out.
Okay. He's come back quickly. One of the GHGSat's key contributions is that the emitters now entered the era where open disclosure of emissions is inevitable. So that's kind of a point you made earlier. Can I add to this sort of discussion on the kind of business and evolution governance side of things? Do you see any regulations coming or being proposed that are going to require monitoring and provide penalties or maybe other incentives for emitters to use your data or to benefit from that?
Yeah, that's very much a work in progress. So as you're probably aware, south of the border in the United States, last January, the Biden administration put out an executive order mandating new methane regulations for the oil and gas sector. And for the first time, not only for new facilities, but retroactively to old facilities as well. And there's actually a parallel process, public consultation process underway with Environment and Climate Change Canada. They've put out a discussion paper for which they were soliciting public comment. And so GHGSat has been actively involved in the consultations, both with EPA south of the border and with Environment Climate Change here at home in Canada. Basically just trying to build awareness that this capability exists, and that we believe this would be very conducive, having measurable objective data being very conducive to these regulatory needs. So we're continuing that discussion.
Okay, good. While we wait for some other questions, I have one that I've been trying to ask people to help students who might be involved or might be participating or who might eventually watch the podcast. Can you identify or highlight any of the skills that students coming through university might want to avail themselves or go after in order to kind of to be ready to plug into this really exciting and forward-looking industry that you're starting?
Well, first of all, I would encourage any student to follow us on socials. So, we're on all the major platforms, Twitter, Facebook, Instagram, and LinkedIn. And LinkedIn in particular is where we post our job opportunities, including student internship opportunities. We are, as a policy, we are never without students. That's also part of the DNA of our company, that we always have students, typically half a dozen students or so at any given time. So please keep your eyes on that. In terms of specific skill sets that we look for. So, things like machine learning, artificial intelligence, big data analytics are things that, that we're very keen on in terms of skill sets. On the hardware side of it, so to be clear, we own the IP for the sensors and so forth, but we don't build any of the hardware ourselves. So as I said, ABB is our trusted partner for the instrument, SFL for the satellite bus, Honeywell for the aircraft instrument, and so so all the other disciplines that you can imagine, mechanical, electrical, software, all I can say is, across the Canadian industrial landscape, the future is very bright. And I think, all of us are always eager to engage bright young people to move us into the future.
Thanks very much for that. A couple of questions have gotten in. We've got them. Eve Cousineau would like a quick question about the aircraft-based sensors. How are they deployed? What kind of flight capabilities are needed in the aircraft? And I think related to that is a comment from Malcolm about this being a business opportunity for the existing airborne survey companies. Do you have a comment?
Yeah. So the instrument, so we don't operate the aircraft ourselves. So we lease an aircraft. In this case, I believe it's a pair of Piper Navajos that we stage out of Calgary. And so basically, and I have to apologize, I don't know as much about the airborne instrument as the satellite, but anything that has like a belly port that we could put the instrument down in is we can operate out of. So we've done flight campaigns in the Montney of BC, in Western Canada, Alberta, the various shale plays in the United States. If there's a specific interest in an aircraft campaign, so my contact information is there. I'd be happy to refer you to our team in Calgary.
Okay. Question from Gerard: do clouds prevent or weather prevent the methane measurements from space?
Yeah, excellent question. Very much so. We do need to be cloud free. Although one of the benefits of the high spatial resolution is that in some ways we can sort of look between clouds. And so because otherwise, if there was high cloud cover for some of these other instruments that may have a bigger pixel sizes, essentially that's sort of attenuating or diluting the signal across the whole pixel, whereas with our higher spatial resolution, in some cases we can sort of look between clouds, but definitely clouds are a no-no. The other thing that we do need, it's a passive instrument operating the shortwave infrared, so we do need sunlight as well. We need reflectance off the surface. So for example, in the wintertime, in northern, in very high latitudes, where the days are short, that's a challenge, and we can't image at night.
Thanks, Eric. Though you were answering questions that I had about the technology. So you had mentioned it's a shortwave infrared sensor.
Yes.
That's used both for the satellite and the aircraft application.
That's correct. Yes.
Yeah. So what is particular about this sensor because spectroscopy, via infrared and all other wavelengths is well established. So how is this sensor adapted for the GHGSat mission?
Well, at this point, I could almost bring Frederic at ABB up to talk a bit more of technical details. But the technology is based on it's called a wide-angle Fabry-Perot spectrometer. So basically, it's two reflecting plates, and based on the spacing of the plates, we can tune it to different wavelengths. So and this is the technology that enables us to achieve, both the spatial resolution and the detection threshold that we're able to do. Now, to be clear, I'm not a scientist, and I'm not an electro-optics person. If there's particular interest, what I can do is we have a scientific paper in the literature that goes into a fair bit of detail, the nuts and bolts and the theory behind not just the instrument, but the retrieval algorithm as well. And in fact, if people have a few minutes, what I might do is I'll just sort of share that in the chat if I can find the chat. Do I have access to the chat? I must. There we go. So if you just hang on for a quick second here, I'll bring up that paper, and maybe in the meantime, while I'm searching for that, I'd be happy to verbally to multitask here and take another question.
I think we've reached the end of the questions. Maybe Malcolm Omer wants to start his conclusion, or I guess I had said that I would thank you on behalf of all of the people attending today. I think we have an international audience and people who are working in the space industry, but also I think your talk is important enough that we've drawn even mere mortal propulsion people into the group. And it's important for all Canadians to be aware of this, and also I think to be proud of the achievement of a Canadian company and a series of Canadian companies in partnership to make an impact on the world. So Eric, I really thank you for your time, and I thank you for your dedication to work for your kids and our kids together in this wonderful new enterprise. So thank you very much.
Well, thank you, Jeff and Omer and to CASI Ottawa. It's my pleasure. This is one of the best parts of my job, is to be able to share what we do. And on the topic of sharing, maybe before the session closes and the chat evaporates. So for people who are interested in a little more technical detail than I'm able to provide, so there's two papers there that explain a little more detail, the nuts and bolts of the instrument and the theoretical basis behind the retrieval algorithms as well.
Thank you, Eric. Thanks for sharing. Thanks for sharing not only your passion, but also your Cat Pancake's passion for space and for Earth observation. So that's so appreciated.
The cat's the boss, right? They just...
On behalf of CASI Ottawa branch, and this is quite fitting because you showed that famous Earthrise photo from Apollo 8, but I'd like to offer you this book by Robert Kurson, The Rocket Men, which is all about the Apollo 8 mission. And if you already have it, then we can have a discussion.
I don't have it. This is beautiful. This is wonderful. Thank you. So generous. Thank you.
All right, you're most welcome. So I'll get that sent off to you very shortly through the magic of the internet. And thanks again to you. That was very fascinating, and thanks to all the participants. We had broad outreach today, as Jeff was saying, and looking forward to connecting with everyone soon, both through the next online presentation, and then hopefully a dinner presentation in the near future when people are comfortable to return to seeing each other in person. So yeah, thanks again.
Okay, thanks everyone.
Thank you.
Stay well, Eric. A number of thank yous coming into the chat from people there. Thanks again.
Well, the pleasure's mine. Thank you. Be well, everybody. Stay safe.
Okay.
Bye-bye.
Good afternoon, good evening.